Hello guys, today we learn how to delete a node at a specific position in linked list using the C program. To implement this, we have required Visual Studio Code, MinGW compiler, and C++ extension installed in Visual Studio Code. Now, when we think about the deletion of node at a specific position, means already we have a linked list containing the nodes. You can see here first node, second, third node and fourth node. There is head and head address of head is 1000 and first 1000 and second node address of content 1001, 1002 and 1003. As you know, a linked list is a data structure consisting of nodes, and each node contains data and pointer to the next node, as you can see in the diagram. Now you can see here there is linked list containing the node. Now I want to delete a node at a specific position 3. Let us see position n equal to 3 means 1 2 3 means I want to delete this node. Now let us see the algorithm. How can do this? Algorithm says that check if the list is empty, traverse the node just before the target node and update the pointer of the previous node and free the memory of the target node. Now let us see. Means if you want to delete this node, we need to transfer to these positions. After reaching these positions, the address of 1002 is the address of this node which you want to delete. And this node contains the address of 103, that is last node. So let us understand how can do. So that if we update the address of this node 1003 to this node 1003 means this node will be d-link and this node will be linked to this node. So that is done. Now how you can do that, let us see through the loop. Now see, I have defined temp equal to head means we will transfers through the address and pointing to the head value in temp, and after that we put integer I equal to 1 and put the loop while I position minus 1, and here you can see temp equal to temp hyphen right angular bracket next and I plus plus. Now let us see. Before proceeding, we have already know we have defined created a linked list which contain the node. You can see here. Now let us move. If put I equal to 1, so what will happen? Let us see. While I 1 less than position minus 1, I want to delete the node at position 3. Now I want to delete the position 3, so here positions value we will take equal to 3. So when we take I equal to 1, first time loop will be run, then I 1 less than 3 minus 1 is 2, means that statement will, that condition will be true, and our pointer here temp equal to temp next. In first time temp equal to head, when you define a temp here, first temp equal to 1000. When this loop will be run and statement will be run, then temp equal to temp next means temp. Here you can see temp equal to 1000, temp next mean 1001. Now this 1000 temp will becomes 1001. So we can put here 1001 means we can get the address of these nodes. So here you can see temp equal to 1000 once, and when becomes, and here I plus means I becomes 2. Then if I equal to 2, then while 2 less than 2 minus 3 minus 1 means 2 less than 2, that condition will false, and this statement will be not execute. And after that you can see our value temp. Temp means we have reached here. To reaching here, address of this node which can be deleted. So simply what can put here? Here presently we are here. So simply we can put here temp next means we can access the address of this. So here you can see also we need to define one pointer next node. So one pointer we can define here in the programs structure node. One is pointer is head, other is new node, and one is temp and next node pointer. So next node we define one new pointers next node, and we will store the address of this node into next node. So you can see here next node equal temp hyphen right angle bracket next means in next node we can the address of means this node. Now after that we need, if you reach here, so we can, I need to update the address of this to this. So after that when we reach here means temp next. So you can see here temp hyphen right angle bracket next equal to, you can see here you have stored the address of this value in next node. So when we put next node hyphen greater and next, so we can access the this node means you can see here next node hyphen greater than right angle bracket next, so you can address the 1003 means in temp next node we can 1003. So finally this node will be updated, this node address will be updated 101. This node, this address will be updated 1003 means this node will be connected now this node, and this node will be delink here now. And for the sake of memory, so also we need to free the memory space. So what we can write now after this free, and you can see the address of this node will store the next node. So simply we can put here next node. So the address of memory will be released, and that is done. So you can see here how to delete a node at a specific position. Simply we put the loop And what we will do, we will run this loop to position -1, so you can get the address of previous node, and after reaching the previous node we will get the address of that node which can be deleted. And after that, when you reach the deleted node, then you can get the address of next nodes, so which address need to update it to here. So after next node next, we can update it, save the value here. Now see this implementation. Now we will see in the program. So here you can see now represents a node in singly linked list. You can see structure node, integer data, and structure node pointer next. Means you already know that structure store the data type of different data type. So we need a structure here. You can define integer value and structure node pointer value next. And I want to delete a node at specific position in a single linked list using the C program. Let us see the program. Here include studio.h, include studio library.h, and include conio.h, that is library functions. Now there is main function void main. Now how can represent a node in single list? Simply we can write here structure node, integer data type, and structure node pointer value next. So represent self. Now represents the head and tail of the single linked list. We define a pointer variable through the structure nodes type. So here you can see structure node, pointer head, pointer new node, pointer temp, and pointer next node. Now in this program you can see the insertion and creating a node in linked list, and then after that we write a program to delete a node. So here we will use to insert the new node through the user input. So here now you can see integer choice, integer position, integer node count equal to 1, and also define integer y I. While you can see a loop while choice create a new node. So how can we do that? New node equal to structure node pointer malloc size of structure node, and print enter the data value. So simply we can write here scan a %d and new node hyphen right angular data. If head equal to 0, then head equal to temp equal to new node. Else if list first we need to check list is empty or not. Both and head tail will point to the new node. So if not, then new node will be added after the tail, such that tail next node will point to the new node. So simply you can see here temp hyphen right angular bracket next equal to new node, and after that new node will become new tail of the list. So simply temp equal to new node. And here you can see, do you want to continue, press 1, otherwise press 0 to. So you can put here scanf %d and choice, so it will get the choice from the users to take new node or not. If you just want to exist, so simply type 0 and this will be exist. And after that new node next, node pointer will 0. And then temp equal to head, check if the list is empty, display all the nodes present in the list. So whatever you have entered the node, now I want to show in the list. So simply what we can put, temp not equal to 0, and we can transfer the node one by one. So you can see here temp equal to temp next, and node count, for node count we have only put node count plus plus, and the linked list is temp hyphen right angular data. So this will print all the node present in the linked list. Now here find scenario, you can see here delete a node at given position. So also need to define a new node equal to dynamic memory location for new node, structure node, malloc size of structure node, and here you can see please enter the position where you want to delete the node. Simply you can position, get the user from position where you want to delete the node, here and position and percent %d, and check position greater than node count means invalid position, and temp equal to head and I equal to 1, we already defined integer value, and here you can see I position minus 1 and temp equal to temp next. This is the loop where we need to transfer to previous node, which node will be deleted, and after that you can see next node equal to temp next, and temp next equal to next node rectangular next, and you can see here free next node means after free the memory and deleting the node. Now I want to show all the nodes in the linked list, so you can see temp equal to head and print now current linked list age, and also you can transfer through the address, so simply temp not equal to 0, printf now linked list element is this temp next, temp hyphen right angular bracket data, and temp equal to temp next. Now you can see all the code in the program Visual Studio Code. Now you can see here all the code here. Run this program again. Please enter the value. Means I want to create a node in a linked list. So put here like first value you can see 1 3. You can put here 3. Press 1 to enter again. Next value 5. Press 1 again. Next value 7. Again press 1, and next value 8. Now press enter and exit this 0. Yes. Now you can see linked list data present in the linked list 3578. Please enter the position we want to delete the node. I want to delete the position third, so I have put 3 and press enter. So after press enter 3, you can see new link list value is 358, means 7 will be deleted. Now you can see the whole program in one go. Thanks. Thanks for watching my YouTube videos. If you want to more videos, please subscribe my YouTube channel.